Hi, in this video, I'm going to use the expected value of the random variable and talk about whether it's worthwhile to buy the Powerball or the Mega Millions. So I already calculate the probability of the winning the jackpot and other cases, and both of them, the Powerball and the Mega Million. You can easily find it from their website. So once you have the odds, you just need to find the one over these odds, then you can find the probability. And you can find the values of the jackpot and so on and so forth, right? And today is March 29th, and the Powerball, the jackpot value is $147 million before the tax, and the Mega Million is $335 million before the tax. And then as you study it, as I want you to recall the expected value of the random variable. So E of the X is a summation xi times the probability xi. So in each cases, you have the value. So that represents the xi's. So the jackpot xi, x is $147 million, and you hit the 5 balls, then you get the $1 million, right? And then each one has a probability. So from there, you can find the value times the probability. And after that, you make a summation, as you can see here, then you can find the expected value. That is same as here, the expected return. So when we have the jackpot for the Powerball, $147 million, it turns out the expected value is 82 cents. But as you know, in order to play this game, you need to pay the $2. So actual expected return is negative $1.18. On the other hand, the Mega Million today, the expected return is $1.35, and the actual return is negative 65 cents. That means that each time you expect to lose 65 cents when you're pulling the Mega Million, and the Powerball is you lose a negative, you lose $1.18. So then you may want to know whether it's worthwhile to buy the Powerball and the Mega Million. And as you can see, the actual expected return is a negative, then it's not worthwhile to play. And in fact, when you get the jackpot, you need to pay the tax. And when you have the $147 million jackpot, it turns out your cash value when you get it is a $79.5 million. So here, when I change to the $79 million, sorry, 79.5. So that being said, here I need to erase 1 zeros. Yeah. So then the actual return is worse. So you lose $1.41. And then the Mega Million is same, even though the jackpot is $355 million, the cash value is only the $187.6 million. So then here it's not the $335 million. I need to change 187. $0.6 million. So then it turns out the actual return is negative $1.13. Okay. So then when is the best timing that you better purchase this Powerball and the Mega Million games? Well, you can calculate it. So here, let me first calculate the summation of the other cases here, these things, except for the jackpot. That is 31 cents, right? And then in order to get your $2 back statistically, so $2 minus this number gives you the $1.68, right? And then divided by this one divided by the probability, that gives you the amount of the jackpot. So let me calculate it. So here, so when the jackpot, I mean, this one is an after tax. You can think that that's a cash option. When the cash option is above the the $490 million, then in that case, you may have the positive actual return. But here, I ignore the taxes for the other cases, these cases. So if you take into account the tax that you need to pay even when you win the game, so then I would say that you need to, when the cash value is around the $500 million, then that's the moment that you need to purchase the Powerball. On the other hand, you calculate the same way for the Mega Million. So let me calculate the summation of these numbers, except for the jackpot. So put the equality summation, and then these numbers, and then $2, that's what you need to pay. So $2 minus this one, that's a $1.75. So this number $1.75 divided by this probability, that gives you the number. But let me change to the dollar sign. That means that when the cash value is above the $130 million, then that's the moment that you better purchase a Mega Million. But what makes a difference? Well, it turns out the Mega Million, well, there are 70 balls and Powerball is a 69 balls. And you can also calculate in general, what's the probability you win any dollars. So like when you hit the ball only, then you get the $4. So that means that when you sum up these numbers, the probability that you win, at least that you get the $4, that turns out to 4% only. That means that when you play it 100 times on average, then you will get the 4 times you win. So that means that it could be you win the $4 or the $7, something like that. And the Mega Million is pretty much same. So summation of these probabilities that you win is around the 4%. And this is a bit higher than the Powerball. So if you don't expect that you get the jackpot or the $1 million something, in general, it's better to purchase the Mega Million because the probability is a little bit higher than the Powerball. So that's it. When you see that the Powerball and the Mega Million, their cash value is around the $500 million something, then that's the moment that you better purchase it. Before it hits the value, the cash value is less than $400 million for the Powerball and the Mega Million, but it's not that worthwhile to play the game. All right, so that was an interesting question. By using the expected value, you can calculate the expected return by playing this Mega Million and the Powerball.